First, let me show you how to do this problem wrong. So I thought this was integers there she's adding to make it 17. So the way to do it is integer partitions. Here it is, of 17. So these are the ways to add up to 17. There are many ways. Okay, so those are the ways. So I will call it partitions, parts. So you just saw it. That's what they are. And now I'm going to multiply them. So I do times add parts. So these are products. Okay, I think I got to do it this way. Oh, I got to do map, sorry. So here. So these are the products of each case here. And so we wanted to see what kind of number it cannot get. So what I want to do is I want to organize it. There are a lot of duplicates. For example, there are 8421, and then there's a, now that I'm looking for it, I don't see 72 and 72 and 72. So some of them are duplicated. So by doing union, I remove the duplicates, and then I also organize it. So these are the numbers I got. And the problem is asking for the least positive integer that cannot be the product. That's how I understood. So let's find it. It's tiring to count here. So what I did was I want to know complement between the range. The largest number is 486. So this would give me numbers 1 through 486. Of those, I'm going to say the numbers I just got. Take out all these numbers out of all numbers, and then this is what I get. So 19 is the smallest one. And that's the wrong way of doing it. The reason it's wrong is because it wanted to see numbers, not integers. So this is bewildering. I mean, this is already a lot of numbers, already a lot of ways here. If you include real numbers, then this explodes. So which one is the largest? To this problem, let me erase this wrong solution here. You have to understand the how to make the largest product. So for example, say a number is 9. And I'm going to do, I will call it part, and integer partitions of the number, which is 9, num. Okay, but this is already too many, so I will just limit to partitions that involve only 3 numbers here. Okay, and then I'm going to multiply them. So what I will do is I will show what the number was and the product of the numbers, product of those numbers. Okay, when I do this here, this is what I get. And let me make it easier to see doing this way. So now, who's the winner? The largest number is 27 here, the largest product. And that happened when these 3 numbers are equal. So there are many ways to split 9 into several numbers here. But when it comes to product, the winner will be one that is as even as possible. The reason I'm showing you with this variable here, because I wanted to show with 10. So when I have 10 here, then it's another story. It becomes many things. And when I do this here, that's what I get. The winner is this, you see, this one that had the least difference among them, most evenly distributed. So even if it could not be all the same numbers here, it tries to be as close to each other as possible. So let me give you another inconvenient number that doesn't divide by 3. So how about 16? So this is what I get. And let's see the product and the number here. The winner is this guy, 150, right? I didn't sort by these numbers here, but so I have to eyeball. 150 is the largest, and they are closest to each other. So that's the crucial part in understanding the behavior of this splitting a number into parts and then finding their products. The largest will be when they are evenly split. Now let's go back up and do the 17, which is the what the problem is asking. And if we do this here, you saw the show before. This is what we get. The largest possible is 180. Well, what if they don't have to be integers? And that's the case in this problem. So in that case, I could choose just a number that guarantees it's going to be the highest number. So that would be this, right? 3 of it. Should I write 3 times? I don't need to, right? And I'm multiplying them, 3 of them. So that's what I get. And if I do this here, I don't have a sense of how big it is, so I'm going to turn that into a number. And this is what I got. It is bigger because the numbers are closer to each other. So this number is looking for the largest. I mean, this problem is asking for the largest integers or the least positive integer that cannot be n. They're getting closer to the n. So we want to see how large this is. And then we got to answer in terms of integer. So we want to see how large this can get. So how can we break this? No matter into how many pieces I break, let's break it into n pieces. 17. Into n pieces. And then if I multiply them, and this is what I get. So this is the largest possible I can get. Yes, there are many ways to split this number 17 into many pieces, but if I broke into n pieces, the absolute champion is this. You cannot get number product that's higher than this. Okay, so we've established that. So what we are going to call it is a product. Let's call it max product with n pieces is that. And I'm going to force it to be an decimal number. So I defined a function like that. Excellent. So what's the maximum product if I broke 17 into 3 pieces? You saw it. That was the number. What if I broke into 4? That was the number. And so on. Okay. So we want to see how high we can go. So how do we do this here? Let's do a plot and take a look. Max product of x or n. Let's use the same term. N goes from 1 through, say, 50. Oh, it's shooting too high. So I will say plot range is full. It's happening around here. And the number is 500. It's happening around here. And the maximum number is 500 something. Very intriguing. So what I will do is I will find out where the maximum is. Find the maximum of the function max product of n in terms of n. It tells me the maximum happens at n equals 6, and that's the highest number. But before we jump in and write down 521 as your answer, remember, we cannot split into a decimal number of pieces. It has to be a integer. So it has to be either 6 or 7. Let's see who's higher. So max product of 7 or 6. Oh, 6 is far higher. Okay, so we go with 6 here. But the thing is, they wanted to know this is n, largest possible number we can get, with splitting the numbers into integer pieces. Not the each number is integer, but we are splitting them. So each has to be split into countable pieces, right? So it will break into 6 pieces. It will produce the highest result, and is 517. But they wanted a number, integer, that is larger than this. The least positive integer that cannot be this. So what's that? It would be 518, and that's the answer.